Hello, James. Hello, hello. How are you?
Hi, Julian. Good morning to you, or good afternoon to you. How you doing?
It is good morning. Good morning to you. Good morning. Good afternoon to me. And what else? Good evening, maybe if you're in Asia or somewhere else on that side of the world.
I feel a quote from the Truman Show coming along at some point here.
Is it freezing where you are?
It is, Julian. I've started in New Hampshire, where the winter is arriving. Not a summer person, so you'll probably be seeing me more wrapped up for the next few months.
Yeah, no, that's good. I've got a reinvent. I've got a reinvent hoodie on to keep it a little warm. I'm based in London, so yeah, it's been cold over the past few days. But funny enough, looking at Vegas over the past few days, that's been freezing as well. I think it's like okay in normal money, -5 or -8 overnight in Vegas, which is like so weird when you go in summer and you're cooking yourself to death, and then winter's just so different.
Yeah, I'm looking forward to the beach. So next year, 2021, is James on the beach.
Oh, that sounds good. That sounds good. Well, yeah, welcome to our Twitch episode. This is what number 4 we're doing out of 6, and literally everything to do with serverless at Reinvent. So thank you so much for joining us. Wow, big James on the wrong one. How about we try that one? James, why don't you go ahead and introduce yourself?
Yeah, sure. So my name is James Beswick. I'm a developer advocate here at the AWS Serverless team. And I've been a DA for about 18 months now, I guess. Before I was a DA, I was a product manager for a long time and also a software developer for many years. And I describe myself as a self-confessed serverless geek because I discovered serverless by accident about 3 years ago to solve a big problem we were having in projects. We had a lot of infrastructure management. So I stumbled across serverless and plugged it into lots of different projects and essentially started building everything that way. So I've had incredible success in my own company with building things serverlessly. So being a DA is great for me because I get to help developers see how they can get the benefits of serverless. But the most important thing on this slide is my email address and Twitter handle. So if you ever have any questions about serverless, feel free to drop me a line and I'll do my very best to help you.
I have to say, James is the absolute guru, the blogging machine, the guru, the blog bez who's awesome. So yeah, he's James is amazing even to have on our team. And yeah, I'm also a senior developer advocate on exactly the same team as James, learning as much as I can from him and everybody else. I'm on Twitter at Julian_Wood and email as well. And I come from a slightly different side of the house when lots of people coming into serverless may come from a web development background or they've been building cool little web apps and everything. I come literally from the infrastructure side of the house. And so I spent way too many years racking servers and building SANs and doing switches and poking holes through firewalls and managing all of that complexity. And that's literally what drove me to serverless, is all the infrastructure stuff we're looking at. And infrastructure is still important. It underpins everything we do at AWS. But it's just such a relief not to be literally worrying about, the color of your cables or whether your striping and your SAN is correct. Never mind operating systems and patching and looking after all of these global kind of things. So yeah, that's what just really intrigued me about serverless. And I've been a developer advocate now for just over a year and a bit. Yeah, year and a bit. And so literally full in, and I'm honestly loving it being internal at AWS, learning about all the serverless things inside. And yeah, what a pleasure it is to be able to share the sort of love and passion I've got for serverless to people. And I mean, to think that this is actually a real job that we get to play with all the cool toys and tell people all about it. So yeah, my experience from infrastructure, from enterprises and startups. You can tell by my accent, I'm not from the US, but born in from Cape Town originally, and living in London at the moment. So, why are we here today, James?
Yes, we've got a few things to discuss with everyone today. And mostly this is interactive, so we're going to be talking through things with Julian and also taking some of your questions. But we're looking through some of the announcements we've had at Reinvent so far. It's been a pretty busy year for serverless. And Julian has a demo that he's got with a lot of these things put together. So it's often, I think, easy to understand just to see how it's all put together. And then we'll discuss a few of the other things that are still ongoing in Reinvent. We've still got plenty of keynotes and upcoming sessions, and lots of fun to check out various stuff. But we've got some tips on how you can find out what's going on. So we're going to squeeze that all into the next 55 minutes.
Let's go, let's go. Also, the questions are live and flying in the Twitch or YouTube comments. So yeah, ask your questions over here. You can stump us if you can. Well, you'll stump me, James, will answer your question easily. But yeah, ask your questions. You can see that this is live and not scripted. So yeah, we'll try and help you out with whatever you are. If there are things particularly about Reinvent or some things about the serverless, yeah, send us your questions or your comments and we'd be happy to address them. So Reinvent releases, do we ever announce anything at Reinvent, James, or does it just sort of go fairly quickly and we don't talk about things?
I think there are a couple of things, weren't there, Julian? There's a couple of small things this year.
Yeah, maybe. What do you got to tell us?
Well, this is the one, it's a big one for me. So 1 millisecond billing is something that we've talked about for a long time. There's been a lot of work behind the scenes to make it happen. So we were super excited to announce this. And really, it's one of those changes that I really like because there's nothing you need to do to take advantage of it. As of right now, all of your billing in December is 1 millisecond billing. So it's essentially a cost reduction, but it does have some really interesting side effects in terms of how you build and architect functions. So I wanted to call out a few things here that are really interesting. So when you look across all of Lambda invocations across all customers in all regions, mostly what you see are very, very short invocations under 1 second. And of those, a very large portion actually are in the 100 millisecond range. So you might have seen the AWS Power Tuning tool where you can take your function and play with different memory allocations to see what the cost performance trade-off is. And while things were being rounded to 100 milliseconds, there wasn't necessarily any benefit really in getting underneath that number because you'd always be rounded up to 100 millisecond bills.
So does that mean people they wouldn't need to optimize their functions, anything running faster than 100 milliseconds, there's no point doing anything, you would just leave it as is?
Yeah, and the interesting thing about this, and Alex Casalboni has a ton of good stuff around this, is that the memory control is a lever for power as well. So when you start playing with the memory control, you can often get very fast executions. But if you're stuck at 100 milliseconds for billing, that limits how far you want to push that. So now with 1 millisecond, things can get really fast. And some of the tests I was doing, I was finding I can save 50 to 70% on the duration of typical Lambda functions that just move, do simple compute functions in my applications. So what I did is I put together this article for Cloud Guru. I'll just paste this in the comments here. What I talk about here is what you can do in your function. It's fairly simple to get underneath the 100 millisecond range in some of these functions. Some of these things you'd be surprised how simple they are. One of them is simply reusing TCP connections. So if you're doing something like interacting with the DynamoDB table, typically by default, that connection is reestablished each time the function is run. By changing a flag on an environment variable, you can reuse the connection. That can have a major impact and save you quite a few milliseconds in your function. Or dependency usage. Often when you're looking at pulling in an entire SDK, you may only use 1 or 2 services. With a slight change in the way that you import those libraries, you can import just these services that you need. And this shaves off sometimes 20 to 60 milliseconds, depending on what you're doing. And then I also talk about where you should init your objects in terms of whether that's in the init code outside of the handler or in the handler itself. And when you do all these things, it's actually fairly quick to implement some of these changes. I was able to get some of my 60 or 70 millisecond functions down to more like 10 or 15. So it's a massive saving in terms of what you then pay for in duration. So I was super excited about this and played with it all weekend when it came out. And everything I learned is in the article for Cloud Guru.
Yeah, that's an excellent article. And yeah, I love the simplicity of this as well. As you originally said, there is literally just nothing to do. Your Lambda bill from December is cheaper. Now, I know some people say, well, that doesn't really matter because honestly, in the big scheme of things, my Lambda bill is tiny because I've got 1 million free invocations per month in perpetuity. So this may not buy you a new house in savings, but there are some companies out there which are doing amazingly complex, huge, enormous kind of things behind Lambda. And so, yeah, this really can move the needle for some of their workloads.
Yeah, and you know, I don't know if people realize just how excited we get at AWS about cutting prices. So it's one of those things where we see opportunities to make an improvement on cost. And then when we pass it along to customers, it's really interesting to see what customers then do and what new patterns emerge. But some of the things I've seen here are that, you know, the free tier is fairly generous already, but you get 400 gigabytes, 400,000 gigabyte seconds per month free in perpetuity on your account. By implementing some of these changes and taking advantage of the millisecond billing, your free tier suddenly becomes much more generous potentially. So I think for people who are building medium-sized workloads, it's obviously great to see an extension of the free tier. For people who are doing very high performance stuff in terms of taking lots of messages off queues, processing streams and so forth, there's a huge opportunity here for saving more money. So yeah, we're just excited to see what people do with this, but it is a fairly seismic change in the way that Lambda billing is being calculated.
Yeah, and there are just two things I'll add to that. One is, you know, behind the scenes, Lambda is always making optimizations. It's always getting bigger, better, faster, more secure, all behind the scenes. And, you know, when 100 millisecond billing came out, that was also pretty sort of revolutionary to think you could have a little bit of compute at that. But, you know, Lambda's got faster all the time. And that's, you know, some infrastructure stuff like, you know, VPC connectivity. Some of their language runtimes also have their own optimizations within the runtimes. And so, yeah, Lambda's getting faster and just faster and faster over the years. And if you've sort of previously just got under that 100 millisecond, well, there wasn't an opportunity. But now with Lambda getting faster behind the scenes, you know, you're literally just getting money back in your pocket without having to do anything else. And that's cool. And the second thing I was mentioning was just the scale of what you can do. And we're going to talk about just you know, larger functions shortly. But if you think of a bigger region like US East 1 or Dublin or things like that, you basically have you can have a initial burst limit of 3,000 Lambda function invocations. So without having to do anything, you can run 3,000 Lambda functions at the same time. If you then need to do more, you can slowly ramp up, and that's, you know, fairly simple to do. The cool thing now is you could run 3,000 Lambda functions for a millisecond and up to 6 virtual CPUs. So you can run 18,000 virtual CPU cores for 1 millisecond. And that's going to cost you, I think it's something like 0.0006 something dollars. Wow. So, I mean, that's very little. Okay, that's 1 millisecond, but that's 18,000 virtual CPU cores. That's only one reason. I mean, I don't know who can do somebody could do the maths and do this crazy thing. If you had to run Lambda in every single region we have, and I mean, even, you know, Melbourne new region coming out in 2022, which was announced yesterday, which is exciting. Yeah. But all of these regions for 1 millisecond, and you know what? Oh, you think you're going to be a bit generous? Well, maybe you've got a workload that runs for 2 milliseconds, and so you just double that. You've got this amazing distributed horsepower with Lambda, which is super simple to go. And so yeah, it's just amazing to think of how much scale you can run for such a short time and cost you very little.
One of the questions we get asked a lot by people is, you know, why does Lambda only run for 15 minutes? Why doesn't it go longer? And I always think it's an interesting question because it speaks to this sort of architecture. Clearly, you know, Lambda could run for any arbitrary amount of time. But I think the design choices that really do well out of this new type of environment are shorter-lived functions, that actually most of these functions where you want to run for 5 or 10 minutes, if you look at the architecture, you can redesign these to run more Lambda functions more briefly and to get better scale with the way that the compute and workload operates. So often when I look at people who are wanting to run larger and longer, they're not necessarily architecting the things to get the complete benefit of Lambda. But it's if any of you are building things where you want more than 15 minutes, let me know, because I'm really interested to talk about your use case and whether it is something where we need to run longer or whether your architecture could benefit from being broken up into smaller pieces.
Yeah, and definitely, I mean, there are always use cases for things running longer than 15 minutes and things that just need to do that way. And sure, you know, Lambda is useful for, you know, many kind of things. But yeah, there are going to be use cases that it's not. But if there's some simple changes that you can do to architect your application to take advantage of Lambda less than 15 minutes, yeah, there's some very simple things you can do to help with that. So yeah, on to the next thing, bigger.
Yeah, so at the same time as doing all of this, we announced an increase in the memory to 10 gigabytes. So that's from 3 gigabytes, where it's been at that point for several years. And also that gives you a corresponding number of cores from 2 when we had 3 gigabytes up to 6 now. So that's a fairly major change. And part of this is really to support all of the new changes to support container packaging for functions. But really, this is extremely important for certain types of workload that typically have had to struggle to better fit within the Lambda memory constraints previously. So now this opens up a whole load of possibilities for machine learning and genomics and gaming and HPC. Machine learning is a really interesting one. We have people here who are building all sorts of models and running inference using Lambda using these new limits. So I think this again is a fairly simple change. You'll see that the new memory settings are available in the console and also through SAM or the CLI or any of the methods that you prefer to use. But actually, it fundamentally changes what you can run within the Lambda function.
Yeah, and as I was mentioning more about this, this sort of supercomputer kind of thing, when you've got this kind of amazing scale, that 18,000 vCPU cores comes from this, 6 corresponding vCPUs. But just going back to the 15 minutes, if you had a CPU bound function that was running and you could only allocate it 2 cores, you were limited to 15 minutes. Now you could potentially have a 2 CPU allocated cores that would take 45 minutes to run before. Well, if it's CPU bound and your application is properly coded for that multi-threading, well, that's going to run in under 15 minutes. So just with this, for example, you could have a 44-minute, 59-second ETL job or something that maybe you had to run on EC2 or in Fargate or on-prem or something like that. And this is a really great way that you could just dial up the memory, you get more allocated CPU cores, and that could run under 15 minutes. Easy win.
Yeah. There's a question here. Is there a way to specify if Lambda should run on GPU for machine learning inference use case? Currently, no, there isn't. So that's something that we've talked about with the product team. But right now, you cannot use GPUs with Lambda. But one of the things you can do is also combine these new features with some functionality we released earlier this year, such as EFS for Lambda, or they'll go back a little bit further and also use it with provisioned concurrency. So some of these workloads actually have a lot of possibilities when you combine these types of services together with the new memory limits and the new virtual CPU capabilities.
So on to the next big interesting announcement that we've had at Reinvent is AWS Lambda container image support. Now, I'm particularly stressing that image support because this is part of an important story that that has been happening through Lambda over 2020. And we're trying to meet customers where they are and help customers use Lambda maybe in more familiar ways than they would have been able to before. So previously, Lambda functions were actually packaged as zip files, if you didn't know that. And whether you created a Lambda function in the console or via the CLI or via AWS SAM or serverless framework or wherever, it was actually packaged as a zip file. That zip file was actually stored in S3, and that it was all behind the scenes. You didn't need to worry about that. But obviously creating a zip file, although that's not hard, it's a different way than people may create applications when they are working in a container world. So we've done a lot of work this year to be able to bring container image support to Lambda. And basically what that means is you can use the Docker CLI plus a Docker file to construct your Lambda function. And this allows you to use your consistent set of tools. So if you're already building Lambda applications, if you're already building Docker-based or container-based applications, and you have tools that already generate container images, and you maybe have some SDKs or some other kind of things that are part of a container image, or you've got third-party libraries, or you've got even some machine learning training data, or you've got anything, a GPS file that's a huge kind of file. You can now really quite easily port that functionality to run on Lambda with an existing Docker file and an existing container. Now,
question for you here, actually, Julian. Is there a base Lambda Docker file that you can use, so you can use familiar syntax but keep the Lambda auto update functionality?
Yep, absolutely. So what we do is it's not just go for your own. This AWS provides two different ways to construct these function images. One is with AWS created base images. So this is for different runtimes, so Python, Java, Node, Rust, all the supported runtimes, and literally within a Docker file, and I'll show you shortly, you just import the runtime, and the Lambda runtime enables your function to talk to the Lambda service. What you can also do is you can decide to roll your own and go, well, I don't want to use the AWS provided runtime. I want to use something slimmer and faster like Alpine Linux, or I want to use Ubuntu, or you want to use CentOS, or literally any Linux-based container image. And then what you can do is there's an additional piece of software called the Runtime Interface Client, the RIC. And the Runtime Interface Client is actually the little bit of code that your Lambda function talks to be able to talk to the Lambda service. And so, yep, build your Alpine Linux from your Alpine Linux distribution, add the little shim for the Lambda Runtime Interface Client, and off you go building a Lambda function. Now, just to mention as well, people get confused because containers is quite a big and a broad kind of thing. And, when people say, oh, I'm going to containerize my applications, I'm going to do all this kind of thing, what does that actually mean? And, there are a number of different things. Containers are an isolation technology. So that's a way you can, using C groups and all kind of things on Linux and on Windows as well, as you can isolate your code from different kind of things. We do that with Lambda already. We have Firecracker, which is a super secure isolation mechanism running at a virtual machine level, not actually at a container level, to provide that excellent isolation. So if you're thinking if you want to do containers for your application for an isolation thing, Lambda's already got you covered. Second kind of thing is there's a whole bunch of tooling. So people are used to using container tooling to build Lambda functions. Tick with this Lambda container image support. And last, the sort of little tick is the packaging format. And this is what we're addressing with the Lambda container image here. So the bigger picture is that you've got some sort of driver to containerize your application. Well, actually, you can do quite a bit of that with Lambda. James, you were going to
ask. Yeah, so Julian, just a couple of quick questions for you, just coming from some of the questions we're seeing here. So one is about cold starts. So obviously we've done a lot to optimize cold starts in the way Lambda was working in the previous world before these releases. How do cold starts work now if you have a 10 gigabyte function?
Yeah, and in fact, we didn't actually explicitly mention that, Lambda functions built as container images can be up to 10 gig in size. So zip functions are 250 meg in size, and these container images can be up to 10 gig in size. I mean, that is absolutely enormous. And that's where we can really put all your dependencies, data analytics, all those kind of things in. But yeah, people are freaking out and going, oh, cold starts. Well, cold starts is really not an issue with these large style Lambda functions because we do some optimization behind the scenes. When you create a Lambda function, even up to 10 gigs from with a container image, and we're going to go through a demo to actually show exactly how that does, we basically do some optimizations on that image. And a big part of that optimization on the image is actually caching it as near to where the Lambda function runs. Behind the scenes, there are some different levels of caching, which you don't really need to worry about. But basically, we will take those Docker file image layers and cache them close to the function. And so you can think if people are running, I keep using Python, but it could be Node, say Python 3.7 as a runtime, that runtime is going to be cached everywhere where Lambda runs. You're going to then add your own dependencies, and those dependencies may be using a third-party utility or something like that. If somebody else has already imported that third-party utility, that's already in the cache. You're going to then create your Lambda function, and basically as many parts of your function are going to be in the cache as possible, and maybe not quite yet in the cache is going to be your first, your actual unique function code. And so when the function gets initialized the first time, that's then going to be copied into the cache. And then, so you will get a cold start penalty, but it's literally going to be the same cold start penalty as if you would for a zip function, because all the rest of the big heavy lifting stuff in the background has already been cached. So we generally see that zip archive functions and container image functions have roughly the same cold starts.
So a quick question on that, Julian. So Damien asked a good question that when you've got a Docker file, will the Lambda service then use the Docker file for all the dependencies and libraries that are installed in the container image? But I was going to broaden that question and ask you, compared to how zip files work, how do the dependencies work in zip files versus now using this container packaging?
Yeah, exactly. So a zip file was up to 250 meg, and there was a way to share dependencies and libraries using something called Lambda layers. And you could add up to 5 Lambda layers to a Lambda function. And what that would actually happen behind the scenes is that would copy the files from the Lambda layers into the /opt directory, and your function would run. With a container image, you actually have more control and more say in how that function image is created. And Lambda layers aren't directly supported in container image format because basically they don't need to be. So what you can do is you can install your dependencies, copy your dependencies as you would for any normal Docker file. So there are a number of different ways, and I actually wrote a blog post about this, which came out last week, some different mechanisms for reusing the functionality of Lambda layers in your container image support. But basically, you would add a container image layer from something which would have a dependency or an SDK. So there would often be just a container image version of that rather than a Lambda layer. What you can also do is if you have the source code, you can just copy the source code into your function, or you can create a container image for that source code in your function and add that to multiple functions. So yeah, there are a number of different ways. Although Lambda layers is not supported directly, it doesn't need to be, because in your Docker file, you can run all those run commands, copy commands, and just add your dependencies directly into your function.
Yeah, so for anyone who's just joining us now, I'm James Beswick and this is Julian Wood. We are developer advocates for the AWS Serverless team. And we're here live to answer questions and also show you some of the new things and new toys that we've been releasing at AWS Reinvent 2020. So Julian, do you want to go ahead and show us now how this developer experience is?
Let's go. So I'm just going to explain a little bit quickly what the developer experience looks like. And basically, if you're from the container world, this will make a bit of sense. If you're from the Lambda world, well, maybe this be slightly new. And a point to make with this is zip file archives are not going away. They're amazing. They're simple. They're easy. This is just an additional way to create Lambda functions. And for someone who's familiar with a container ecosystem, this may be an easier on-ramp to them from Lambda. But yeah, don't worry, zip archives work all the same as they have and how we've loved them for 6 years now. So the developer experience is you create a container image, and that's built from a Docker file. And as your standard commands in a Docker file, most of the commands in a Docker file, you build your Docker image. You then Docker push, which will take that container image you've done and upload that to Amazon Elastic Container Registry. So that is Amazon's, ECR is Amazon's public hosted container registry. You can have private images, you can have public images. And then what you do is you basically create a Lambda function from the console or from your favorite CLI or something. And you can just pull the config that's from that, pull that container image to then build your Lambda function. And that'll do some optimization on the side, pulls the image from ECR, does the optimization, and builds your Lambda function. And you have your Lambda function up and running as if it was a zip function. The source code, in effect, has come from ECR. And then you invoke the Lambda function just as you have done before, from the CLI, behind API Gateway, behind Event Bridge, behind the 140 plus different services. And so that workflow just builds up to create your Lambda function.
Yeah, so we've got a quick question. When you're using container images, is that calculated into the regional limit of Lambda storage? How does that work?
Container image format actually works slightly differently because ECR does have a way. ECR basically charges to store your container images. It's not a punitive charge, but basically your Lambda function storage is now no longer a zip archive in S3, but it's actually stored in ECR. So I don't believe you actually pay for any Lambda storage for your ECR or for Lambda storage for these functions, but you do pay for the ECR. Also, because things are in cache, a lot of that data is also shared as well. So yeah, you do pay to store your image in ECR, but once it gets to Lambda, there's not an additional charge to store your Lambda function.
What about patching and upgrading images that you build? How does that work?
Yeah, absolutely. So that's one of the differences with this container image format is with some of this control, you need to take on a bit more responsibility. So a container image is immutable. Once you create a container image, you can't change it or amend it or add to it or remove from it. And that's a good thing because there are many scenarios where you actually want to be able to test your container image and not have things change under your feet. And we've got many customers who write their Java applications, their Node applications, their Python applications. And behind the scenes, we do a great job of patching and updating those SDKs or that runtime. But there is a risk if your code has some really deep connectivity into those SDKs that it could cause a breaking change. And so this does solve that scenario of what you can do is you can create an immutable image, and you then know 100% the image that you created in perpetuity will always be the image that Lambda runs. Now, obviously, one of the powers of Lambda is having that whole auto-updating process. So when you do take this on to have more control over your image, your mutable image, you then do need to have some operational capability to then update that function configuration. And you can do that in a number of ways. You could decide to, once a week, update your Lambda functions. That will be immutable as well. Run your unit tests, run your integration tests on it. And when all your testing comes back all green, you could then deploy that Lambda function to a production image, and that would be then your new Lambda function. So you do get some more control about exactly what happens in that image, but you do need to take on some of the responsibility of then keeping that up to date.
Just one more question, then I'll let you keep going with your demo. So the question from a viewer saying, is Lambda running the container or something else? Can they run native Go apps?
Yeah, good question. And Lambda, the easiest way to explain it is actually Lambda is not running the container. Lambda is building a function from the container image. So Lambda is all about event-driven applications, and that all means sending events to Lambda, which then invoke based on those events. Traditionally, if you're building Docker files or Docker applications, you maybe more understand the port and socket model, where you expose a port and a socket to the outside world, and then you run something within your Lambda, sorry, not within your Lambda function, within your container like Nginx or something. And when a request comes in via that port and socket, your then container does something. For a Lambda function to run, it still needs to be an event-driven application. You don't need to concern yourselves with ports and sockets or everything, but you need to build your application, your function, in a way that it can still take advantage of the Lambda event-driven model. And that's what that runtime interface client from a technology perspective does.
Great.
So yeah, there is a question about tags. We'll literally go into that shortly when I go through. Just this slide was the SAM developer experience, and we're literally going to show that as quick as I can. And SAM does all the packaging in the container, pushes it to a repo, and creates the Lambda function with a single command super well. There is just a quick question coming in about the 10 gig applies to container images as well. It's actually the other way around. Container images can be up to 10 gig. Zip file functions can still only be up to 250 meg. And the reason for that is due to the caching. Because we can cache container images, we can support much bigger sizes. We can't cache zip archive functions in the same way, and so the cold start time would just be too much. So another thing I'm just going to go on quickly is Lambda extensions. So Lambda extensions is a new way to add more functionality to your Lambda functions. And there are three different parts of it. One, where you can use extensions, and an extension may be something like an observability tool, or something to pull things from Secrets Manager, or HashiCorp, or Datadog, or Splunk, or Sumo Logic, or all these different kind of great partners. You can consume an extension from them, which gives some more functionality to your Lambda function. And that functionality enables you to pull information from Lambda about the function invocation. And partners in AWS and yourselves can use extensions or write extensions to use this for observability, for example, for taking logs out, for monitoring, for security, for secrets management. There's a whole world around Lambda extensions, which I encourage you to have a look at. The 3 links on the slides here are 3 different blog posts which look at the different capabilities using extensions, just how to use an existing extension. If you want to build an extension, there's an API which you can do that, the second one. And then there's a more recent functionality, which is logs, which I'm going to show, where you can basically pull logs from Lambda and send them directly to a destination of your choice without having to go via CloudWatch logs. Extensions are easy to deploy. You can deploy them as a Lambda layer. or you can include an extension in a container image, because as we've mentioned before, the Lambda container images doesn't directly support Lambdas, but you can just bundle your extension in a container image, because ultimately it's a bunch of files. And those extensions are little processes that run, and they run as a separate process, separate to the function. And the cool thing is they can start up before the function runs, and they can run after the function finishes. So you can do some setup things, you can do observability or grab some telemetry even before the function runs. And after the function runs, you can continue running that extension, maybe send logs somewhere, maybe send your tracing data somewhere. So it gives a whole bunch more flexibility for your for Lambda.
So with extensions, when you expose this new event model that's available with Lambda, as a developer, can you build your own extensions?
You can build your own extensions. So in fact, I'll say on this slide, which shows it. And before, what we had was just the runtime API. So when I talked about the RIC, the runtime interface client, that's how a Lambda function talks to the Lambda service. Well, now with the extensions API, you can build your own extensions, and you can hook deeply into the Lambda lifecycle. So you can register to say, whenever a function invocation happens, whenever a function is going to be shut down, or whether a function initialization is going to happen, let me know. And then the extension can do something. An extension can register as an extension and then also register with the logs API to say, hang on, I'm going to run a TCP or an HTTP server, and anytime you've got any Lambda logs, you send them straight to me. So yeah, definitely a lot of functionality. Use your extensions or write your own extensions to integrate your own tooling.
And is there a template that you can use to springboard your development from?
Absolutely. I've got a link coming up a little bit later, and there's a whole bunch of sample extensions which you can fairly easily run.
Great.
So this demo extension is basically uses the logs API, and it's literally a cool thing that's going to take logs directly from Lambda and I'm going to send it to an S3 bucket. So why don't we start building? So let's bring up the code. Demo time. Let's just get the right screens up. So here we are. I have a very simple Lambda function, and all it's going to do is it's going to say hello from Lambda. And what I'm going to do in this demo is I'm going to show how we can combine Lambda container images and extensions. The first thing I need to do is log into ECR. And this is just a simple command, and that basically gives me a token, and the ECR is where I'm ultimately going to copy my function. Next I need to do is I need to create a repository within ECR, and so that's really simple. And that creates a repository where I'm going to store my image. Now, what I'm going to then do is I'm going to use some Docker commands, and if I head into the folder, I can look at the Docker file for this function. I've got some things that are hidden at the moment, which we'll just get into a little bit later. But basically, I am going to build a Python 3.8 image. And in a single line, I'm just going to pull the Lambda version of the Python runtime directly from the public ECR repository. And that's going to allow my application to talk to Lambda. Super simple in this Docker file. All I'm going to do is I'm going to copy this app.py, which is this file over here, and I'm going to copy that and say that my function code is the app.handler. So I'm going to do one kind of thing. I'm going to build the Docker image, and that basically, if we look over here, this Docker build command is literally going to say, I'm going to build it, and I'm going to tag it with the log extension function, and I'm going to call it the manual one. All that goes through, and that's just going to use a normal Docker build to build it. I'm then going to tag it. That's just using the normal standard Docker tag commands. So you can see I'm not using anything AWS specific yet. I'm literally just using the Docker CLI to do this. And then what I'm going to do is I'm going to then push this image, which all it does is contain this Lambda function, and it's just going to push that up to ECR. So that's going to take a few seconds because we can actually see the size of the image is 200 meg. Because that is containing the Lambda, the whole Python runtime. So in the background, if you know Docker, you know this is all these different hash values over here are basically different layers which are included within this Python image, and it's just pushing those different layers up to ECR. And ultimately, when we build our Lambda function, those different images are going to all be individually cached. So we're nearly getting there. I think maybe the cold is affecting my internet speed.
Hey, Julian, so
Yeah,
could you use Cloud9 to do this and take advantage of any sort of network
yeah,
benefit? Or what's the
absolutely.
best way to do this?
Yeah, that would be a great use case. I'm just showing how to do it in VS Code because that's where your application development choice may be. I'm also doing this on Windows. So even though I'm using, very much a Linuxy style development flow of using Docker files and everything, I'm actually developing on Windows. But yeah, absolutely, you could use Cloud9. Then you're literally on the AWS backbone, and that is going to be super quick to be able to, push and pull any of your images.
Yep. While we're waiting for that, just a couple of questions for you. So what about code build? How does this fit into the code build flow of development?
Yeah, there's a whole bunch of parts of the code build thing that work really seamlessly with this. Part of it is building those Docker images, which you can do. And I'm not going to avoid the question now, but what I'm going to say is our colleague Rob Sutter is going to be coming out with a really interesting blog post on how to integrate this whole Docker workflow into your CI/CD pipeline. And yeah, part of that is going to be on code build.
Great.
All I'm going to do here is that's not going to work because I haven't created the function already. All I'm going to do now is I am going to create a Lambda function. And here's the little different thing. What it does is this package image format. And this is then pointing to the image I've created in ECR. Now, I'm going to let that run. And then what I'm actually going to do, the Lambda function is being created. And all I'm going to do is then I'm going to jump over quickly to the console. And I can see I now have a repository which we created. That was the ECR repository. And we had that image that was pulled up. And we've got a Lambda function. Has the Lambda function been built? Yeah, the Lambda function has been built. And if we just had to walk through quickly looking at the actual config of this Lambda function, we can see it doesn't have a preview because obviously it's built into an image. And this is the image URI. So we can see over here is we could override the entry point CMD and workdir overrides. If you know about building Docker containers, you know how all these kind of works. And otherwise, it's a normal Lambda function. And I can test this Lambda function. And I can create the test invocation. And off I go. I've got a Lambda function. Hello from Lambda. That's what the status code is. That's done. If I was to hit it a few more times, just interestingly, you can see there's the duration 1.06 milliseconds, and I've been billed for 2 milliseconds. So looking back at that build duration. So basically, we've just created a very, very simple Lambda function, but used a container image format. I know there's a bit to go through. There's a blog post on this. In fact, there are multiple blog posts on this, which I'll show you a little bit later. So don't worry, you could literally do this yourself, and off you go. So what am I going to do is I'm going to then do this in SAM. And so SAM, if you know about SAM, has a template file. And all SAM says is, I want to build a function using package type of image, and I am going to use a Docker file. And where's the Docker file stored? In functions src. So that's literally going to use the same Docker file. It's going to use the same function code and just use SAM. And that's as complicated as this. I do the SAM build, which is basically going to do the Docker build, and that's built my function. I can also use SAM in local invoke. So I can now locally invoke my SAM built container. So that's pulling a container image. That's that runtime API daemon, which is pulling down, and we've pulled from Lambda. So we've got a container image. SAM has built a container image, and SAM has run locally a container image. Super cool.
So when you use SAM to build these applications, Julian, what happens with ECR? Do you need to create the repo beforehand, or does SAM handle that?
You do need to create the repo, and I'll show you exactly. You do need to create the repo in advance, and that's the current state. We are working on making SAM a little bit more slick to be able to do that. So when you do SAM deploy, that asks me the region, and this is where it's going to ask for the image repository. Because I've actually created this before, it's remembered it, but that is just going to say the image repository, and off it goes through, and it's going to go and build my function. You can see the layers are being uploaded already. You can see a number of those layers already exist, and the Lambda function is going to be created. Now, this is a bigger application. It's got an S3 bucket, which I'll cover shortly. But yeah, look how simple that was. SAM build, SAM local invoked it to my unit testing locally or do something locally, and SAM deploy, and that whole image has just been pushed up to ECR, and then the function has been built from that ECR repository.
So in the SAM template itself, what are the specific attributes that have changed? Compared to where you regularly just build a SAM template using a zip file, what's new here?
So they're actually things that you remove, because you don't need to put a whole, basically the three kind of things are, you want your package type as an image, and the metadata, which basically says which Docker file do you want to use and what is the source of that Docker file. Because you've got a lot more power in your application, so you're actually, a lot of the intelligence about what is being built is going to be here within your Docker file. And if you've got any requirements or you've got any library dependencies, you will build that here in your Docker file. And I'll show that briefly.
One of the things I really enjoyed when I was playing with this is I discovered SAM init. So SAM init gives you a skeleton application with a hello world example, but it provides you with the Docker file, and it makes it super easy just to go and change the function and then deploy without necessarily knowing much about Docker.
Yeah, absolutely. SAM init, and off you get going. When I started learning about that, that was the easy way to get going as well. So if we look in ECR, we will actually see I now have another image which SAM has pushed up to ECR. And I hopefully have another function. And this is the function which has been created by SAM. And literally, if I was going to test this while it's launching, I can just run a test with whatever. Now, obviously, this is going to work. We don't expect to be anything different, because this is literally using SAM to build the same Lambda function from the same source code. So you can use the Docker CLI, or you can use the SAM CLI to build your function from the same source code. Super easy.
So a lot of the examples I've seen show how you use API Gateway to integrate with this to trigger and invoke the function. But can you use it with the integrations with S3, SQS, and all the other types of Lambda integration that we've been used to?
All of the integrations are exactly the same. Remember, this is just a different packaging format for your Lambda function. The way you invoke your Lambda function behind API Gateway, step functions, S3, all of that remains the same. This is just a way to build your function in a different way, but the way it integrates with IAM, with all of that around the rest of the Lambda ecosystem remains the same.
One question here from CopperTop. Is there any performance improvement to using the Docker build method?
The Docker build method over SAM build. I wouldn't think so, because ultimately it's going to be the same. It's going to be the same artifact that is created on the back end.
Actually, one great question, and I won't let you keep going, is about, would this serve as a better replacement from using a scheduled Fargate task that uses a single image that executes and finishes in under 30 seconds?
If your image is built to be an event-driven application, so it can accept events and then send the results onto somewhere else, yep, sounds like a great use case. If you are doing a port and socket-based thing, you may need to do some refactoring.
That really is the fundamental difference, isn't it, between the Fargate model and the Lambda model? In a nutshell, I think you just covered it.
Yeah. So I need to breeze through this quickly, because time goes, James.
It really does.
So I want to basically, so that Lambda function does very little, just responds. But what I want to do is I want to add a Lambda extension, which has a bunch of code over here. We don't need to worry about that. And that extension is going to register with the extensions API, register with the logs API, and send logs directly to S3. So this extension has got a different Docker file, which we're going to build from. And what it's basically going to do is it's going to create, here we're going to package up some requirements. And in that requirements, because it's going to be copying some, sending to and from S3, it's obviously going to need the bot03, which is the Python client, which is going to talk to and from S3. And so here we can see within the Docker file that using a multi-stage build, we're going to copy the files, copy requirements, install the requirements, and then we're going to copy that into the Docker image. So simply put, if I'm going to create a container image for this, what I'm going to do, I'm going to do the same kind of thing. I'm going to build and tag it as a log extension image and call it the latest one. I'm going to tag that locally. and I'm going to push this extension up. So basically what I've done now, helps if I always create a repository for that. So just fix that, log extension image. So there we go. Super complicated to create that ECR repository. And we push that image up. So you can see this is smaller. I decided to use just a part, because this has only got the dependencies and it's basically bot03. I won't go into the detail of the Docker multi-part build, but this is a cool way to really slim down. I was going to say slim down your applications. So basically all I've done now is I've created this extension. I've got this extension and I've uploaded this as a separate image. What I'm going to do now,
So just one clarification from people are asking about, because I think the audio cut out briefly, but can you just talk about the performance aspects of Docker build, SAM build, and how it's run in terms of just the overall Lambda performance?
Yeah, so that's a different thing. The Docker build or the SAM build is actually just creating the artifact for your Lambda function. And if you're doing pip install, if you're doing npm install, or all those kind of things, that's only at build time. That performance has really got nothing to do with the actual running of your application. Once everything is packaged, the difference between the zip and the container image we've talked about as well with the caching. But yeah, the actual Docker build or some other way you're building your Lambda function is a separate performance thing from the actual running of the function. And SAM build is also using Docker behind the scenes. So basically it's using a Docker build to build that file, but that's only going to be a once-off when you create your function. That build process isn't happening every single time you run your function. That's a separate part. So just quickly jumping back into the function, all I'm going to comment out is to say, you know what, import this layer. I'm going to say copy that layer to the from that layer into the opt directory, so that function will run. I don't actually need that because I haven't got any requirements for this. But if my function did have some specific requirements, I could install it over there. And so literally to import this extension, I've done 3 lines. I've said I want to, from that public layer, from that public container image layer, and copy that into my function. I then, where am I? I need to go into my function directory and I do a SAM build. So what SAM build is now going to do is that's going to add that that's going to add that Docker image into my function. Did I actually save that? Let's just make sure I'm not going to waste my time later when it hasn't done anything. All done, and I'll do a SAM deploy. And by the magic of SAM, this is now going to pull my updated function, which I've basically just added, and you can see that 55 meg, the extension files into that function. So I'm going to leave that function over there. If we look back at ECR while we're just waiting for that to be created, remember we now have 2 separate repositories, one for the image and one for the function. Let's just wait for SAM to do its kind of thing. If we then look at our function, nothing would have been changed. Part of this as well is because it's going to, part of that SAM template was to actually create an S3 bucket. So we're just going to go into that to try and speed up a little bit of time. And we can see there's nothing in the S3 bucket. So that Lambda function is now being updated. And you can see over here, because it's a Lambda, when we were talking about the build stage, that is going to be a little bit slower because it's going to be packaging up that Lambda function. And this is just in a pending state. If you had any function invocations that were happening at the moment, they would still be using the old version of the Lambda function. And only once this update is complete will the new invocations happen to the new function. So same Lambda function. I've done nothing else. Haven't changed the code. The Lambda function is all the same. I've just literally added an extension to it. And we run the function again. And that's whizzing through. It does take a little bit longer because it's got some log kind of stuff. And I can see already here it's pushing things to logs. We run it a few times. You can see now how faster it is for the subsequent invocations. And quickly heading over to S3, I now have my logs in S3. So I haven't changed any of my function code. I've just added a logs extension. I didn't even look at that code. I didn't even need to understand that code. And that is now grabbing, using the extensions API and the logs API to pull information directly from my Lambda function and send it to S3.
So then you could use that data that you've got in S3 to use that with Glue or QuickSight or some other tool, typically for processing large amounts of logs.
Yeah, absolutely. And also you can use some iron policies to stop the logs going to CloudWatch logs. So what you could do in your logs extension is you could do some filtering if you didn't want to keep all of your logs. And so this is a way to dump your logs elsewhere or not process them, and also save costs with potentially not storing your logs in CloudWatch logs.
Now, if people want to go through the code that you just showed in more detail, because I know we've gone through this very quickly, do you have that available to anywhere on GitHub? Or
yeah, there we go. So here's all the Lambda extensions demo code. So that's using building and extensions, and there are 2 logs API demos. One uses the zip archive format, and one uses the container image format. Use this QR code, and there are many more examples also in Bash, Node, Python, Ruby, and Go for parts of the other extensions.
Great, Julian. Well, thanks so much for that demo. So we're rapidly running out of time here. We've only got 4 minutes left. Amazing how time flies.
Yeah. So James, just take us through Reinvent.
Yeah, so we're in Reinvent 2020, which this year is 9 days across 3 weeks. So these are the Tuesday, Wednesday, Thursday sessions. Right now we're on the 8th, so we're almost halfway through this whole session. But there's also lots of other things going on. So you've got the late night plays that run on Monday night. So last night there was one where Brandy Carlisle performed, and you can catch that on replay. They're all recorded and available to watch. There's also, we've just heard about, there's 2 keynotes coming up. We've got Werner's keynote on the 15th, so that's next Tuesday, and also David Richardson's keynote. He's the leader of Serverless. He's got a lot of interesting things to say around that just towards the tail end of the event. And
if you are searching for these, David's is actually called a leadership session, but because he's ultimately the boss of Serverless, we're upgrading him to a keynote.
Makes sense.
And he pays the bills.
And also, we just announced that we've got a range of news sessions that are being released in January from the 13th to the 15th. And so this is really all the extra content we couldn't fit into everything over these 3 weeks. And so when that happens in January, those will be released. And the Serverless team has a whole range of sessions. I've got 2 sessions myself coming out then. So there'll be more to come, but just know that come January the 13th to the 15th, there are a wave of extra sessions.
Yeah, and there will be a session on deep dive and Lambda extensions, and also on the container image support. So yeah, just quickly looking back, because we're in week 1, at the end of each week in Reinvent, all of the week sessions are made available for viewing. So during the week, they're actually live for one session. And the cool thing about being live is you can actually ask questions, and it's often the speaker and humans behind it. So even there, it's a chat. It's not a chat bot or anything trying to answer your questions. We have real live human experts answering your questions based on the sessions. Then there are 2 repeats for different time zones, as Reinvent awesomely this year can be more global. And then on the Friday, all the sessions are released. So these are the serverless track sessions from last week. Suggest you take a look at it. If you're getting started building applications, look at Emily Shea's. Lego is a great use case, step functions, and data at any scale from Danilo. Also looking, that was the serverless sessions. These are the builder sessions, and these are from Amazon principal engineers, literally our brightest engineers in the whole company, and they have created these amazing presentations. So monetary production services at Amazon, David Janacek. A super good one is actually Claire Liguri's automating continuous delivery pipelines at Amazon. You may think, that may not apply to me. This shows you how we deploy globally in AWS, and Lambda follows the same kind of mechanism. It's got really good, useful information on how you can deploy to a single host at once, then roll out to a single region or availability zone to multiple regions, and using waves deployments. And even if you're only doing on-prem kind of stuff and you're wondering how you could deploy to a single cluster or a single host or multiple data centers, there is useful information in that for you.
So we're down to our last 40 seconds. So we'll just run through some of these very, very quickly. But this is what's coming up this week. And today, there's the serverless LAMP stack that's presented by Ben Smith from our team. So if you're a PHP developer, that's pretty interesting. Also, if you're interested in SAM, Alex Wood has a session today. But you can see all of the sessions that are coming up on the Serverless Land website. We've got a Reinvent 2020 link, so you can catch up with the entire agenda there, and also on the official site. We've got 2 more of these sessions coming up from people in our team on the 10th and the 16th. You can catch everything on youtube.com/serverlessland or on Twitch/AWS. And so now we're out of time. So once again, I'm James Beswick, and this is Julian Wood, and we've been talking about Lambda releases. So thanks for joining us. I hope you'll follow us on Twitter, and hope you enjoy the rest of your reInvent.
Yeah, thanks very much. Please continue either via Twitter if you want. If you do have additional questions, James and I prepared this and we thought, yeah, we've got plenty of time. It's amazing just how much there is to cover. So yeah, sorry if it is going a little bit quickly, but there are going to be many more sessions at reInvent to go into this more deeply. So yeah, please stick around. Please ask us questions via Twitter or various other kind of mechanisms, and we'd love to help you. And most of all, have fun building serverless applications. And we hope after reInvent 2020, it becomes even easier and you can do even more with serverless.
Thanks very much, everybody. Have a great day.
Bye-bye.